Hi girls, this video is going to take you through how to complete pages 5 and 6 of your electricity booklet. So on page 5, first of all, which has the title Now Your Turn, what you need to do in this page is to design an electrical circuit. And that electrical circuit must have 3 lamps, in other words, light bulbs and 2 switches. You must be able to have all of the following possibilities. All lamps off, only 1 lamp on, only 2 lamps on, and all 3 lamps on. So you're told here to, on rough paper, draw a circuit diagram to show your idea. You might want to sketch this down and do it quite roughly first of all, and then if you think it will work, then draw it out neatly. And that's step number 2. And what you must remember is that when drawing a circuit diagram, what do you need to use? You need to use a pencil and you need to use a ruler. And remember, there must be no breaks in the circuit. There must be a complete path from the battery to your lamps and back to the battery. But remember, your circuit must have all 4 possibilities of having all lamps off, just 1 on, just 2 on, or all 3 on. So you have to design your own circuit. And again, as I said, try it roughly first of all before drawing it out neatly. One hint I will give you is that your circuit's going to have to be a parallel circuit. So look back to what you were doing yesterday on series and parallel circuits and how parallel circuits are a branched circuit. And in order to have all of these possibilities, your circuit is going to have to be a parallel circuit. Now, there's more than one way of doing this, but I would like to check that your circuit actually works. So when you have this work complete, when you have designed your circuit and you've drawn it neatly in the space below, and make sure it's in pencil and ruler, that means if it's wrong, then you can rub it out and try again. When it's complete, please submit a photo to the assignment on Teams. I'll check that your circuit works and I will let you know. Now, just to say, you can ignore step 3 for now because that involves you being in a science lab and having this equipment and being able to set up your circuit and try it. So you can ignore step 3. So you need to pause the video now, give that exercise a go. Once you've finished it, just get your photo submitted to the assignment on Teams while you're at it, and then come back to this video for how to complete the rest of page 5 and page 6. So hopefully you have that task completed now at the top of page 5. And we want to move on to your second task for today. So that is about the steady hand circuit. So look at the bottom of page 5 for your instructions. You probably all have played, or if not, you should have seen this steady hand game. And what we want to do is to draw and label a circuit diagram for this game. This game works that if the metal loop touches the wire, then the bell will ring or the buzzer will sound. Some of these actually use a lamp instead of a bell. So you have to draw and label a circuit diagram to represent this circuit. Remember, you'll need something to provide the electricity, so in other words, a battery. You'll need wires, you'll need a complete circuit, but also an opportunity for the circuit to break and for the sound not to be heard. So this is quite tricky, but have a go. Don't worry if you're not sure, just think about it for a little while. If it's not completely correct, that's okay. Do it just on a file page or a blank page within your booklet, if you can find one, or on the back page if it's blank. And give this a go, just doing it roughly. And then again, if you draw it out neatly, if you find a circuit that works, then draw it out neatly using pencil and ruler. So give it a go, but there is a photo on Teams if you're stuck of the correct circuit diagram. And just like the previous task, there are a few different variations of this answer. And so yours might look slightly differently, but if you're really not sure, have a look at the diagram on Teams and see if that gives you any ideas, and maybe you could try and draw one that's slightly different than that one, but that still works. And remember, essentially you want a circuit diagram that will work that if this metal loop touches the wire, the buzzer will sound, but if it's not touching, we'll not hear a sound. In other words, there'll be a break in the circuit. So again, pause this video now, give that task a go, and then play the video again for page 6. Now that you've completed page 5, we're going to move on to page 6 and we're going to look at the idea of conductors and insulators. There's 2 things to help you with this page. First of all, there will be a video from Miss Wallace demonstrating this practical at the top of page 6, and that video will follow on from these instructions. After that, you'll see a video from Dr. Ross, and that will be explaining the section at the bottom of page 6 on wires. And if you need any further help, there's a link to a BBC Bite-sized video in today's instructions document that you can use if you need some extra support. After you've done these things, you should have page 6 completed. So let's take a look at those videos now.
Hi girls, I'm going to work through page 6 from your notes with you, and this is to do with conductors and insulators. So it says to set up the following circuit, bridging the gap with the various materials listed. Here are the materials. Note whether or not the lamp glowed in each case. So let's have a look at the circuit first of all. It's drawn here for us. We've got 2 batteries side by side. I've set that up just here. The positive terminal is at the left hand side, just here. And we've got a bulb, placed it just here. And then we've got this arrangement here, which is a gap where we're going to place our material. The first thing I want to check is that our 2 batteries and our bulb are working okay. So I'm going to connect this little simple series circuit up to check that all of our equipment is working. So we've got just one continuous loop, and there we have it. Our bulb is lighting. We've got 2 batteries and only 1 bulb, so that's why our bulb is lighting really very brightly. Great, all's working. So let me take that out. Now we need to create this gap section just here, and we do that using these little fellas. These are crocodile clips, and they connect into the end of the connecting wires like so. So I've connected one in there to the end of that connecting wire that's coming from the battery, and now I'm going to connect in the other one from the bulb. Put that in there. There we go. And if I touch these 2 crocodile clips together, we should be completing the circuit. Yes, we are, and the bulb is lighting. Break it, touch it again, there we have it. So we're going to place different materials in between the 2 crocodile clips to test whether or not the bulb lights with those materials. So the first material on your list is copper. Here's a little piece of copper. So I'll connect it just there. And I've got to be careful to make sure that my 2 crocodile clips aren't actually touching, and they're not. But you can see that the bulb is lit. So does the lamp glow? Yes, it does. Next material is steel. Here's our steel. Connect it between the crocodile clips. And the bulb, as you can see again, does light. So that's another yes. Let's try wood. You might have your own thoughts on this as to whether or not the bulb will light with this. There we have it connected. The bulb is not lighting. So, no. Paper. Again, you might have your own thoughts on whether or not this is going to allow the bulb to light. As we can see, the bulb's not lighting. Next one, glass. Here's a piece of glass. Connect it between our crocodile clips. There we have it. The bulb doesn't light. And the last one, a piece of aluminium. So what we're using here is a piece of aluminium foil. Connected together, the bulb lights. So girls, this table illustrates the materials that are conductors and the materials that are insulators. A material that allows electricity to flow along it is a conductor, so the copper, the steel and the aluminium are all conductors. A material that doesn't allow electricity to flow along it is an insulator, such as wood, paper and glass.
So the
This is some electrical wire used in the house. So this is a cable. And we're looking at the inside. So you're to say what material you think this is made of. Now don't try to be too specific. Just generally, can you see what sort of a material this is without trying to give away what you've answered above? So what type of a material is that? And why should it be made out of that material? Do you know why the inside has to be made out of that material? So keep it simple. You should hopefully know from what I've just shown in the experiment. And what about the outside? This here, what do you think that is? Look at any cable in your house, maybe connected to your computer. What material do you think that is, and why do you think it's important that it's made out of that material?